Hello dear students, welcome to the online platform of UTKARSH classes for NEET and JEE. I am Jitendra Singh and I will be teaching chemistry for NEET as well as for JEE. Basically it is an introductory class for the upcoming course we are going to launch on 1st of May. So today we will start with the chemical equilibrium. That is one of the very basic and important topic. And it's interesting as well as. So first question arises that what is chemical equilibrium is. Before moving towards the chemical equilibrium, we should know what is equilibrium. Basically, the meaning of equilibrium is a balance. A balance between two opposing forces. If two opposite forces cancel out each other, then this particular state is known as equilibrium. For example, I just explained, I am applying the force by these two hands in opposite directions. If this force is I, then it will move in this direction, and if this force is I, it will move in this direction. But if the both hands are having the same force, or you can say the magnitude of the force is same, then they are in a state of balance, they are in a state of equilibrium. So it's very simple that whenever two opposite force balance each other, then it is known as equilibrium. Now question arises, what is chemical equilibrium? Chemical equilibrium is maybe defined as, it is the state of a reversible reaction. Here the important thing is, equilibrium is possible for the reversible reaction only. As all we are knowing that a reversible process takes place in both direction, forward as well as backward. So it is the state of a reversible reaction in which the concentration of products and reactants are unchanged over time. Means there is no change in a concentration of either reactant as well as product. For example, if we take this, as we are knowing that this is the sign of reversible, we are all knowing that it is the sign of reversible process. If it is irreversible, then the sign will be like that. So it's a reversible process. Here, whenever the rate of formation of ammonia from nitrogen to hydrogen, this we are talking about this step. So this rate, that is also known as RF. RF, what is RF is? This is the rate of, you can say RF is the rate of forward reaction. It is the rate of forward reaction. It means the rate of formation of ammonia is become equal to the rate of backward reaction. What do you mean by a backward reaction? Backward reaction here is actually, you can say, the reaction by which ammonia decomposed and produces nitrogen and hydrogen. So you can say formation of ammonia is a forward process and the decomposition of ammonia is a backward process. So what is RB? You can say this RB is actually the rate of backward process in which the ammonia is going to decomposed. So what we can say, what do you mean by chemical equilibrium? Basically, it is the state whenever RF is become equal to RB. You can say whenever RF is become equal to RB, means what we are saying that the two opposing force should cancel each other. Here, what do you mean by two opposing force? The one is formation of ammonia and other one is decomposition of ammonia. It's a common sense that these two are opposite of each other. Formation of ammonia and decomposition of ammonia. So whenever the formation rate of ammonia is equal to or it is balanced by its decomposition rate, then it is known as the state of equilibrium. So how we can define it? We can define it for a reversible process, state of equilibrium is the state whenever the rate of forward process is become equal to the rate of backward process. Or you can say the state whenever there is no change observed in the concentration of reactant as well as product. So the concentration of ammonia remains constant as well as the concentration of nitrogen and hydrogen remains constant with the time. So I hope you get the basic definition of the chemical equilibrium. Now we are moving towards the next slide in which we are representing it graphically. You should understand how to read a graph. Basically, it is a plot between two variables. So here we are taking one is as a concentration and other one is a time. So what you will have to understand about this graph. Here this shows the concentration of reactant, as it is clear that the concentration of reactant decreases with the time. It's a very basic thing. The reactant should decreases in a process. So the concentration of reactant decreases with time while the concentration of product increases with time. But at this point of time, as you see, the concentration of reactant is constant as well as the concentration of product is also constant. So you can say this time t represent, you can say, establishment of the equilibrium. So this point of time equilibrium state is obtained, as after that point the concentration of both reactant as well as product are remain constant. So I think it is very clear. So how to represent a concentration time plot? Now we are moving towards the second one. It is also a plot between concentration and time, but one difference we observe. At this point the concentration of reactant is equal to the concentration of product. But here in this plot we are not having any such point in which the concentration of reactant is equal to the product, but still we are having this point T. As you see, at that point and after that point the concentration of reactant remain constant as well as the concentration of product remain constant. So what important conclusion we can draw by these two plots? Always remember, for an equilibrium what we want is the concentration of reactant and the product should remain constant. It is not necessary that they are equal. Always remember this point, because in general students are confused with this problem. They are just confused with that either it is same or constant. So remember, for chemical equilibrium what we want is concentration should remain constant. We are not going for the equivalence of the conductance. We are not saying the concentration should be same. What we are saying is concentration should remain constant, and it is very clear that if the rate of the forward process, or you can say the rate of two opposite process are equal, then there is no net change observed. Okay. Now we are moving towards the third plot. That is the plot between the rate and the time. So it is the plot between rate and time. So what we observe? This point T represent the state of equilibrium, because RF is become equal to RB. As we have already mentioned, for any equilibrium state we need RF is become equal to RB. This is the basic condition required for equilibrium. RF should be equal to RB. One more thing, here RF is decreases with the time. As you see, RF decreases with the time while RB increases with the time. You can ask why it is so. So it is very simple. Basically it is forward process, it is backward process. Initially we are not having product, so RB is 0. You observe here that the RB is 0 at initially, because we are not having the product. Initially we are having reactant only, so we are having RF only, and with the time this RF decreases and RB increases. For example, let's hydrogen and iodine combine and produces twice HI. So initially we are having hydrogen and iodine only. So with the time these hydrogen and iodine are converted in HI, so the concentration of hydrogen and iodine decreases while the concentration of HI increases, and that is the reason why RF decreases with time while RB increases with time. You are observing here, or that point is RF is decreases, RB increases, and at a point whenever the RF is become equal to, as we have already mentioned that whenever RF is become equal to, we are getting the equilibrium state. So dear students, what important point we have already mentioned here is at equilibrium the concentration should remain constant. Listen carefully. The concentration should remain constant while rate of both opposite process should be equal. In case of rate we are saying it should be equal, but in case of concentration we are saying it should remain constant. You should understand these 2 points. and I hope you will get this. Okay, now come to the next slide. In this, we are talking about the characteristic of an equilibrium. It means how we can identify the equilibrium is present in that particular reversible process. So the first nature is very important, that is dynamic in nature. Now first we have to understand that what is static and what is dynamic. Just see here by a simple example. I can explain this by a very simple example. I am just standing like that. I am in a state of balance, means I am in a state of static balance. As I am not moving, there is no process is going on, I am just in a state of balance. This is known as static equilibrium. But I am running just like that, running on a treadmill. So what happened? I try hard to push myself. I am just running like that. So I try hard to push myself forward. But the treadmill pushed back me in the backward direction. So whenever the force applied by me is equal to the force applied by treadmill, then the state of equilibrium is obtained. I am just running, but I am not moving. You should clear about this. I am running, but I am not moving. Means the process is going on, but still there is no change observed. This is known as dynamic equilibrium. If I am standing like that, it is static equilibrium. If I am doing like that, but I am not moving forward, it means this is dynamic equilibrium. So always remember that in case of chemical equilibrium, it is dynamic in nature. Means the process remains continuous after equilibrium. Just for example, nitrogen and hydrogen combined, as we are knowing that it's a Haber process, and they produce ammonia. So in this process, whenever the equilibrium has been established, still the nitrogen hydrogen combined and produces ammonia, and ammonia decomposed to produce nitrogen and hydrogen. It means process remain continue after establishment of equilibrium. So I hope you get the point that what is dynamic nature, process remain continue after equilibrium. It is not stopped just like I just hold this marker or the electronic pen like that. This is static equilibrium. There is no process is going on. So the dynamic equilibrium in which the process remain continuous. So the second point is it can be attained from either side. Now first we will have to understand what is the meaning of this. It can be attained from either side. Just for example, if I take this nitrogen and hydrogen in a closed vessel, after some time you will get this ammonia. After some time this ammonia will start to decompose and we are getting the equilibrium. That is already we have mentioned that. I mentioned here closed vessel. Remember that for equilibrium we need a closed vessel. If this vessel is open, then ammonia will escape. So there is no ammonia, no equilibrium. It's a simple concept. The one state will escape, so no equilibrium obtained. In case of a closed vessel, we are in a state to obtain the equilibrium. So what we are saying is, it can be attained from either side. Means, if we start with the nitrogen and hydrogen, after some time we will get equilibrium state. And what happen if we will start with ammonia? If we will start with ammonia, then also after some time the equilibrium establish. That's what we want to say. That the equilibrium can be established either from the reactant or from the product. If you will start with reactant, then also you obtain this one. And if you will start with the product, you can ask why it is so. So it is very simple. This sign is the answer, as the process is reversible. So it will take place in both the directions. So I hope you get this, that it can be attained from either side. What is the meaning of either side? It is either from reactant or from product. Now come to the third point. We have already discussed about the third point, that all observable properties, you can say what is observable properties? Observable properties that we can observe. For example, you can observe the color of this shirt. So it is observable properties. The color is the observable properties. So all observable properties like concentration, color, pressure, density, they are remain constant. We have already mentioned about this one. Not only concentration, but all other observable properties remain constant after equilibrium. This statement is already explained by me. Okay. So now I am summarizing whatever we have learned about the chemical equilibrium. First, we understand what is equilibrium. Equilibrium is the state of balance. I have already mentioned this is the state of balance. Two opposite forces cancel each other is the state of balance. What is chemical equilibrium? It is basically a state of reversible process in which the rate of forward reaction is become equal to the rate of backward reaction. So this is known as the chemical equilibrium. Now we have gone for three different kind of plots. The one is in between concentration versus time, other one is also in between concentration and time, and the third one is rate versus time. And the most important point is at equilibrium concentration remain constant. Always remember, concentrations remain constant while rate of forward and backward process are equal. Okay. Third one is your characteristic. In these characteristics, we have explained about the dynamic nature. I have told you the dynamic nature means the process remain continuous after equilibrium establishment. And the second one is it can be obtained either from reactant as well as from product. And third one is very simple, in which we discuss that the all observable properties like concentration, color, pressure, density, they all remain constant. So dear student, I hope you understand that what is basically the chemical equilibrium is. Throughout the year, we'll always focus on concept. If you learn the concept, you can solve any problem. Just believe me. If you learn the concept, no problem will bother you, whether it is NEET level or a JEE level. If concept is clear, you can solve any doubt, because the numerical or the questions are application part. So for application part, we should have clarity of concept. Okay, so this is just an introduction that how we are going to teach or the learn chemistry throughout year. So we'll start this course, and please do subscribe to UTKARSH channel for the NEET and JEE course, in which whatever we are doing here, one more thing is whatever we are doing here will be available in form of PDF. Either you are watching it on YouTube or on UTKARSH app. Whatever I am doing here is available in form of PDF format. There we have online test, we are having quiz, and such all requirements we are going to fulfill. So hopefully we will in touch, and just subscribe UTKARSH channel. Thank you.